Good morning, everyone, or afternoon, depending on where you are today. Thank you for joining us for the webinar. Olivia, do you want to go to the next slide? Oh, yeah. So in 2011, EPA released our school siting guidelines to assist school districts in avoiding environmental hazards when identifying locations for new schools. One of the most prominent concerns was siting schools near large roadways and the potential for children to be exposed to high levels of air pollution from traffic. Many schools and parents noted that quite a large number of schools were already located near large roadways and wanted to know what they could do to mitigate existing concerns around exposure to traffic emissions. In response, EPA developed and released the Near Road School Best Practices Guide in 2015. We continue to promote these best practices as effective options for reducing pollution exposure at schools, but we are also interested in reviewing and updating this guide. For this webinar today, we'll review the concerns around exposures to traffic emissions at near road schools and the mitigation strategies summarized in the existing guide. We would appreciate any comments on the existing guide, as well as suggestions for additions or changes that could be incorporated into the planned revision. Throughout the presentation, you will hear from experts Rich Baldoff and from the EPA and Olivia Ryder and Doug Eisinger from Sonoma Technology. Additional expert panelists from the EPA, Ken Davidson and Chad Bailey, will be on the webinar to answer questions. Special thank you also to Michael McCarthy from Sonoma Technology and Dahlia Chasen from Arab North America for their work on developing the original guidance. When this guide was originally published in 2015, COVID-19 was not an issue. We anticipate and hope that COVID will be a short-term concern and not affect public health and school operations over the long term. However, we believe that many of the strategies reviewed in the guide will also be beneficial for reducing COVID exposure. On the other hand, we also recognize that some recommendations may not be conducive for reducing COVID exposures. If you have any questions about the information in this presentation as it relates to COVID-19, please use the Q&A function to provide us your question. Next slide, please. Just a quick housekeeping note, please use the Q&A option at the bottom of your screen to ask questions during the presentation. We will have a fair amount of time at the end of the talk to answer questions that may not have been answered in the slides. After the presentation, we will send out a link to the slides as well as the recording of the presentation. I'm going to turn things over to Rich Baldoff to kick us off.
Thanks so much, Sarah. Appreciate it. Here's an overview of what we'll be presenting today. I'll start out with a brief introduction, kind of some of the key factors and reasoning behind the need for this guide, what some of the near road air pollution concerns are, what's air pollution at schools like, how it can be mitigated. And then we'll hear from Olivia Ryder and Doug Eisinger from STI about the guide itself and provide overviews on some of the mitigation areas and strategies. Then as mentioned, we'll have a quick summary, and then we hope to have quite a bit of time for question and answers today as well. So you can, again, for those who have joined since Sarah mentioned it, if you could put your questions in the Q&A box, and we'll have people monitoring that throughout the presentation as well. So we can go to the next slide. So in just the last couple decades, there's really been hundreds to thousands of health studies that have shown people living, working, going to school near large highways and other transportation facilities, such as airports and rail yards, face an increased health risk. One of the seminal studies in this area was done back in 2010 by the Health Effects Institute, where they did a meta-analysis, again, of hundreds of health studies that had been done at the time, where they found a link between exposure to traffic-related air pollution and exacerbation of asthma, as well as suggestive evidence, fairly strong suggestive evidence of causal relationship with other things like incidence of asthma, other respiratory diseases, lung function, cardiovascular effects, and even premature mortality. There have been quite a number, again, hundreds of thousands of studies even done since the Health Effects Institute report as well. And in addition to the adverse health endpoints that HEI noted, there have been a number of other studies as well, linking things like cancer, cognitive, including childhood leukemia, of course, which is important for children and school issues, but also, again, cognitive development as well. So we can go to the next slide. We also know that concentrations of air pollution can be very highly elevated near roads, especially within the first 150 to 300 meters of the road. I won't go into this graph per se, but this represents a resource, another meta-analysis done around 2010. Again, a number of other studies have been done since then showing similar results as well. And especially if you focus on the left, what we can see is, within the first, especially 100 to 150 meters of the road, we can have very highly elevated pollutant concentrations, with some pollutants as much as 10 times higher within that first 20, 50 meters even versus further away. But we can still see elevated concentrations at 300 meters and even in some instances beyond that. So again, this raises the concern where exposures to air pollution, especially from traffic, can be very highly elevated in this short distance. So we can go to the next slide. And even though this is a short distance, there is still a very, very large population potentially exposed to these higher pollution levels. And these are just a couple statistics to highlight that fact. We estimate that over 50 million people live within 100 meters of a large highway or, again, other transportation facility like airport or rail yard. But, as you can imagine, since highways are so ubiquitous, not just in the United States, but throughout the world, that a lot of this population is near these large roadways. A study done in 2014, also referenced in the guide, estimated about 17,000 schools in the US to be within 250 meters of a heavily traveled road. Again, since that was 2014, that number has probably even increased since then. And at the time, that was representing about 6 million children attending classes at these schools. And to the right, you see a picture, again, just showing an example. Many of these schools are directly adjacent to these large highways. So this is just a couple examples. So, many within that, high pollution impact area. So we can go to the next slide. So again, just a real brief background on, what is traffic-related air pollution. What do we expect to be elevated near the road? And this slide just provides an overview of just some of the, hundreds to thousands of pollutants that can be elevated actually near the road that are emitted by motor vehicles. Many of these contaminants are, either known toxics themselves or can contribute to other air pollution. For example, carbon monoxide gases, nitrogen oxides, things like benzene, and then volatile organic compounds. Volatile organic compounds, or VOCs, can be toxic by themselves, but can also contribute to other pollutants like ozone. Also of concern is particulate matter. So solid or liquid aerosols and particles that are suspended in the air can pose a adverse health risk. We know things like PM10, PM2.5, which are indicators of the size of the particles that we have regulatory standards for. We also have some very, very small particles, which we tend to call ultrafine particles, which are so small they can actually pass through the lung to blood barrier And so compounds that are really small, such as even black carbon, can fit into this size range. So black carbon is also referred to as soot, and it's often that black smoke that we see from diesel vehicles. So again, these are just a handful of some of the pollutants of concern. Particulate matter especially has been shown to at least be a suggestive cause of a number of the health effects from air pollution. So it is an area that we do tend to focus on, and you'll see a lot of focus on that in the guide, although again, we do try to address all of these pollutants. So we can go to the next slide. And these are, again, the sources that we look at from traffic activity. So again, we can have the exhaust from cars and trucks, which can emit those gases that I had mentioned previously, as well as the particles. We also have brake and tire wear, which can be a fairly significant source of particles as well. And then as debris or the particles emitted by the vehicles settle on the road and more activity occurs, as these vehicles drive on the road, they can be resuspended and be another source of especially particulate exposure in this near road environment. So we can go to the next slide. And a lot of people often ask, what is a large roadway? What is a major road? When should I be concerned? And while we don't have actual thresholds, because things can vary, so we don't want to say there's a magic number above it's a concern, below it's not, but we do have some guides out there which can give kind of a bit of a rule of thumb or a kind of an estimate for an existing school if they really want to explore this more and see if they do have some concerns. So one example is California, where they actually have legislation trying to limit new schools being sited near large roads. And what they've used is for what they term here is rural, but also we could call it arterial roads where there's stop and go traffic. The estimate is about 50,000 vehicles a day where we start to have some concerns. And for what they're labeling here as urban, which could also be considered highway or limited access roadways, about 100,000 vehicles a day. New York also considering similar legislation, instead of classifying roads, just uses 80,000 vehicles a day. And then the Federal Highway Administration also has a recommendation on what's considered a major road. Now, that's not in the context of air pollution per se or school siting as well, but again, they try to use about 50,000 vehicles a day as a reference for what could be a major road. So again, these are some considerations, not thresholds, but considerations of when traffic emissions could be a pollution concern. And we can go to the next slide. And again, just to give some examples, especially of the California one where they differentiate arterial roads versus highways. To the left is an example of an arterial road with about 50,000 vehicles a day. One of the issues with these arterial roads is that they can have stop and go traffic, idling, other things that could cause higher emissions on a per vehicle basis. So that's why we tend to look at a little bit lower volumes still as being a concern for these types of roads. To the right is an example of a typical urban highway. This one's about 200,000 vehicles a day. It's very common in most, if not all of our, relatively large urban areas. So this is not an uncommon traffic volume at all in the United States. So again, can be a concern and something to think about as far as near road air pollution concerns. So we can go to the next slide. And I think I'll turn this over now to Olivia. This is our first webinar question for the day.
Thanks, Rich. Yeah, so I'll go ahead. I'm going to launch this poll and it's optional to participate. The question is, do you know of any schools located near a busy roadway? And so this could include a school where you work, one in the district, or perhaps where your child goes to school, or in a school community. So I will launch this poll now. Give you about 30 seconds to respond here, and then I'll show everyone the results. Got about 50% of people. Give you a few more seconds since people are still responding here. Okay, and then we'll close it in 3, 2, 1. Okay, so looks like yes, most people, 63% of the people that responded are well aware of a school that's within at least a football field's distance from a busy roadway. So that is useful to know. And then Rich, I'll turn it back to you for the mitigation areas.
Okay, thank you, Olivia. Thanks everybody for participating on the poll. And as a heads up, we will have a number of questions throughout the presentation. So again, we appreciate everyone's participation. I did just a couple more things, a little bit of background in reference to the guide itself, and really in general as well, when we're looking at mitigating health concerns related to traffic and other sources of air pollution. We tend to focus on these three areas. So the emissions themselves from the vehicle, the source of the air pollution. We also look at methods to control the levels or concentrations in the air. And we also then look at trying to reduce the actual exposure that, in this case, the child or staff member at the school are exposed to. And we do try to address each of these three mitigation areas in the report. And I think you'll hear a little bit as Olivia and Doug go through the report itself, how they address some of these mitigation areas. So we can go to the next slide. I do want to mention, though, one of the EPA's missions is to do emissions and activity reductions for motor vehicles. So there are a lot of activities going on. We have both regulatory and voluntary programs that focus on reducing the emissions themselves. So again, the report doesn't necessarily go into detail on these regulatory or voluntary programs focusing on motor vehicles in general. However, we do have recommendations on using technologies that meet the latest emission standards as shown here. We also reference voluntary programs such as the National Clean Diesel campaign, anti-idling that can be used to reduce emissions at school sites, as well as potentially being funding sources for mitigation activities. In addition, from an EPA perspective, we also have programs trying to reduce vehicle activity itself, such as promoting public transit, promoting active transportation, so walking and biking to work, or walking and biking to school, I'm sorry, and other aspects like that to, again, try to take vehicles off the road. So we can go to the next slide. And this is my last background slide. And again, really just trying to highlight the different microenvironments of concern, as well as areas that we do try to address in the guide. So going from right to left, we actually have exposures during the commute to school, whether it's children on the bus or in a personal vehicle, their exposure in the car. We also have right nearby on the sidewalks. So again, kids that are actively commuting to school, walking or biking, can be exposed along their route to school or at school itself when they're arriving at school, or kids, again, loading, unloading off school buses, entering, exiting their personal vehicles, again, potentially having that exposure when they're near traffic, as well as potentially idling vehicles at the school itself. We also have playgrounds or athletic fields, and surprisingly, very many of these can be located right next to major traffic routes. And that can be especially concerning because kids are often very active in these locations. Their breathing rates are high, and so their exposures can also be very high to the air pollutants during these times. So again, another consideration in the guide. And then of course, there's the school itself, and outdoor air can enter into school different ways. There's passive ways where they can get through, where the air pollutants can get through open windows, open doors, or leaks or cracks within the shell of the school itself, as well as active air intake for the school ventilation, circulation systems, and things like that. So again, the guide tries to address all these different, microenvironments and ways that air pollutants can kids can be exposed to air pollution in these different microenvironments. So with that, I think we go to the next slide, and I can turn it over to Olivia to start talking more about the guide itself.
Thank you, Rich. Yeah, so we're going to be going through the review of the guide. So we're going to go through how, or rather the guide goes through how near road exposures can be reduced in schools. It goes into details about building design and operation strategies that could be employed. And those include ventilation, filtration, and indoor air, as well as actions that occupants can take. There's also site-regulated strategies such as transportation policies, site location and design, roadside barriers, and then a summary. And we're going to go into some of these points today, although not all of them, because that would take quite a while. But when the slides are sent out, you'll be able to click on the picture of the best practices slide here, and you'll be able to, or picture of the guide here, and you'll be able to visit the guide if you haven't already and check it out. And so now I'm just going to launch our second poll. So let me get that up. And 1 second, here we go. So in our second poll here, there's 2 questions, so you'll have to scroll down to see the second one. But it's before today's webinar, had you heard about EPA's free downloadable best practices document? And how would you identify your primary affiliation, just so we can get a better idea of who our audience is today? I'll give about 30 seconds to answer this one. And just as a reminder, if you do have questions, be sure to use that Q&A button at the bottom of the screen or possibly at the top of the screen, and we will try to answer questions as we go along in the chat or in the Q&A function. Okay, looks like numbers are leveling off. So I'll close it in 3, 2, 1. Okay, looks like there's a majority of people who haven't heard of the best practices document, so you're in the right place. And then it seems like there's a good spread of people from state agencies and schools, academia, and others as well. So that's great to know. Okay, so jump into this. So there's a number of strategies that can be implemented, as we've sort of alluded to with this document before, that can be used to reduce pollution from roads near schools. And so in this table, they're grouped together by the overarching approach that they take. And we've also indicated which of the 3 mitigation areas they target. And while there's a lot to digest in this slide itself, you'll be able to look at it closer once you have the slides. But the important thing to note is that all of these strategies, they reduce exposure. And then a number of them also target more than one mitigation area. And we can think about these same strategies in terms of who has control over each of them in order to make improvements or to make changes. And so in this version of the table, the rows are colored in green to show the strategies are under individual school or district control. And that's primarily operations and building design approaches. And then those that are in the peach color are within the community or the local government level control. And so those include corridor management and street design approaches. And then finally, those that are in the sort of peach to green color are both within the school and the community or local government level control. And so that includes some corridor management, but also barrier use, which is where you could implement a vegetative barrier or a wall around a school or within the school grounds. And so that might require some input from both groups of decision makers. And on the right-hand side of the table, we've indicated whether these strategies could be applied to existing schools and or whether they would need to be considerations more for newly built or currently being planned schools. And one last thing to note here is that of all the strategies that are listed, they all target gas and particle pollution reduction, with the exception of HVAC systems, which would need to have an additional charcoal filter in order to remove gases. And so that would be a lot of material to cover again if we were trying to focus on all of those strategies today. So we're just going to be focusing on the ones that are within the school and the school district control, specifically pertaining to operations, building design, and barrier use. And with that, we're going to launch quickly our third poll. There's 4 polls total. The other one will come at the very end. So we will be asking the question of which of the mitigation approaches that I just listed are you familiar with prior to this presentation? And I know that we haven't really explained too much about them, but just based on the table in the last slide, which ones do you think you are familiar with? So I will launch the poll now. And you can choose as many as are applicable. Okay, getting some answers here. That's great. Give you about maybe 10 more seconds here to choose the ones that you're familiar with prior to this presentation. Okay, and I'll close it in 3, 2, 1. Oh, it's a flurry of activity. Okay, I'll end the polling now. So that's great. It seems like people are pretty evenly aware of a number of these strategies, so that's great. And we'll go into more details on the ones that maybe people are not aware of so that we can make you aware of them. I'm sorry, there was 2 more questions on that one as well, which I'm assuming people saw because I saw the numbers go up. My mistake. Okay, so the strategies for existing. The first one that we'll go into is going to be HVAC improvements. So improving or installing HVAC filtration systems. And this strategy can really be most effective in helping to achieve large reductions in indoor particle concentrations. And again, as was mentioned earlier, these materials and recommendations were really developed before the COVID-19 pandemic. And so during COVID, some of these strategies might not be feasible. However, again, we hope that this will be a temporary situation and these recommendations will once again become fully applicable. But until then, a judgment call may need to be made about which strategies can be safely implemented during this time. And having said this, a co-benefit of improving the HVAC systems is actually the possible removal of COVID-19 containing particles in the air, and also improvements to the energy efficiency at the school. And in this section, we'll also discuss the special case of portable or mobile classrooms. So just some terminology to make sure everyone's on the same page. So HVAC filter efficiency is designated using a minimum efficiency reporting value, or MERV rating scale. And so filters with a higher MERV rating are more effective at removing small particles. And you can see this in this schematic that we have at the bottom of the screen here. And I'll use my laser pointer. So you can see, for example, that MERV 6 filters are designed to remove these large particles such as lint or dust or pollen, while higher rated filters build on each other in terms of removal. So MERV 11, for example, is designated or designed to remove the same particles as MERV 8, but additionally also dander and smoke. And MERV 13, for example, builds on MERV 11 and also is designed to remove bacteria. And there's something else to keep in mind here, is that the MERV ratings run from 1 to 20, and these higher end rated filters, such as 19, 20, those would be used in clean rooms or hospitals. So the first recommendation to improve filtration is to upgrade the filters that are being used to the highest MERV rated filters that the HVAC system can handle. And so EPA is recommending 8 to 13. Another consideration is to install pre-filters, when these are also known as bag filters, upstream of the main filters. And so that's going to help to maintain the lifetime of the main filter. And the pre-filters are also typically lower grade, and so they're less expensive to replace. And you could also consider upgrading the HVAC system itself to accommodate a higher efficiency filter. And depending on the age of the HVAC system as well, you might also want to consider sealing or resealing the ducts to reduce infiltration of outside air, which would diminish the overall effectiveness of the filter system. And so filtration is only going to be effective, as you can imagine, if the system is properly maintained. So including regular filter replacements, not only of the main filter, but also of the pre-filters or the bag filters, if you have those in place, is going to be critical. An air intake for classrooms should take either filtered air or fresh air from the furthest away point from traffic or other pollution sources, and that includes both furthest away in terms of height and also maximum horizontal distance when possible. But air intake should also, when they're being placed, an important consideration is to keep them as far away as possible from other air pollution sources as well. So that could involve chimneys, that could involve, traffic, bus stops, places where cars or buses idle. And also to keep in mind, timing is important as well. Because you can timing when the air is being taken into the building to avoid rush hour when pollution levels outside are quite high is important. And so if the windows or the doors on the building are leaky, this could cause issues as well, as you'll have leaking from more polluted outside air into the building. So it's important to seal these leaks, and that's also known as tightening the building envelope. And something that's often overlooked actually is communicating with staff and students as to what is going on and how their efforts can help ensure the benefits of using an HVAC system. As I said, is often overlooked, but in doing this, it ensures that the windows and the doors aren't left open by teachers and staff, which bypasses the benefits of using the HVAC system itself. And that could also lead to premature degradation of the filters or the system. So this communication is really key. So moving to the special case of portable classrooms, there's actually over 300,000 portable or mobile classrooms in the United States. And the EPA has guidelines about choosing and maintaining these types of classrooms, and you can access that guide using this link, which will be available in the slides when we send them out. And due to the nature, as you can imagine, of these portable classrooms, that they're susceptible to multiple issues. And these include sometimes poorly functioning HVAC systems, loud ventilation systems, water entry and mold growth, pollution from nearby parking lots or loading areas, as that's often where they're actually located, and also less secure building envelopes, so leakier buildings in general. So some recommendations when attempting to improve the air quality in these sorts of portable classrooms, or alternatively, in classrooms that are naturally ventilated, so maybe a regular classroom that doesn't have an HVAC system, is to consider using portable or standalone filter units for those classrooms that aren't equipped with central filtration systems. And care should be taken as well to ensure that they're appropriate for the occupancy and the size of the room that they'll be used in. If window filtration units or HVAC are available, definitely utilize the highest MERV rated filter that the system will allow for. And if the portable classrooms have an HVAC system or a filtration system in place, consider upgrading the system if it's necessary. And then similarly to the main buildings, tightening the building envelope is critical, but care should be taken to ensure sufficient total ventilation to address mold or potential mold issues, and also along the same lines to ensure the correct indoor humidity levels to prevent condensation issues. And these are likely going to depend on the climate where the school is located as well. So these will differ for different schools in different cities and different states across the nation. So it's important to keep in mind that the cost for upkeep and maintenance should be considered when installing new filters. So specifically, the practical lessons learned from schools that have implemented some of these approaches that we've outlined here include planning for this future maintenance. And that includes having knowledgeable staff available for maintenance needs. And you might also consider installing pressure gauges across the filter banks, and that could help more easily identify when filters need changing or if there's leaks in the system that need to be addressed. And also as a side note, it's important to also keep in mind that other events might quickly degrade the filters as well, and that could include wildfire smoke. So it's important to factor in how the HVAC system is being used during these sorts of conditions, and then how that might impact the lifetime of the filters and their ability to work efficiently. Just something else to keep in mind. Another important lesson learned is that educating staff and students and parents about the efforts and really emphasizing the importance of keeping windows and doors closed during the hours when the HVAC system is active in the building can really help ensure the filtration remains as effective as possible. So as with every move to make improvements, there are advantages and drawbacks that need to be carefully weighed in order to fit your specific needs. So on this slide, what we're doing is summarizing some of the advantages and the drawbacks specifically associated with improving the HVAC system to be compatible with a higher efficiency filter. So the primary advantage here is that it'll allow for larger reductions in particle concentrations. And the drawbacks might include the initial cost of upgrading the system, and then also the possible reduction in efficiency if the building envelope is leaky. And now the exact costs will, as you can imagine, depend on the individual situation, including the system that's currently in place, the one that it's being replaced with, the room size, occupancy level. But what we can do is qualitatively estimate the initial cost and the operation of maintenance costs that might be ongoing. So here, the initial or the capital costs of upgrading the system is estimated to be high, where there might be redesign involved and compatibility concerns to take into account. However, the ongoing costs of the regular maintenance that might be associated with maintenance that is outlined by the manufacturer, those costs are considered to be relatively low. And overall, improving the HVAC system to design to accommodate higher efficiency filters would produce large air pollution improvements, or as we have designated it here, the mitigation benefit of this strategy provides is high. So perhaps the system is appropriate, but the air intake vents are located near or facing a major roadway or some other pollution source where buses or maybe cars drop off students. So the advantages of relocating the air intake in this case would be a reduction in both the gas and particle pollution that's being drawn into the building. And this can help increase the lifespan of the filters as well. However, the relocation of outdoor air intakes can be costly. So depending on the existing mechanical system, So it's recommended to upgrade the filters first before moving to this approach. And the initial capital cost would be medium to high, and that's based on the need for redesign and the actual relocation of the intake itself. But the ongoing operational costs would be low because once you've moved the intakes, they shouldn't need to be moved again. And so overall, the benefits associated with relocating the vents would also be high. So now we'll switch to time awareness as a strategy. And this focuses on identifying periods during the school day when there's high traffic or high pollution levels that are around the school. And then taking that into account and scheduling outdoor activities such as recess or sporting activities or events, or even opening doors and windows outside of those times to minimize the exposure to air pollutants. So in terms of recommendations in this area, the main focus is really on training teachers and staff on the best ventilation practices during the times of high pollution at the school. So this would include training on when to keep windows and doors closed in mechanically ventilated classrooms, so those with HVAC systems or filter systems, to prevent the entry of polluted outdoor air. And also when to have windows open or closed in naturally ventilated classrooms during peak commute time. So those would be classrooms that don't have HVAC or filter systems in place, but use windows and doors to ventilate the classroom. And of course, we understand that this may not always be 100% possible to open and close windows, as there's possible situations where a schoolroom has insufficient ventilation, or there might be COVID-19 regulations that necessitate increased ventilation. So opening a window or a door might be required. So again, some thought and judgment calls may need to be made here to weigh the trade-off. And this also goes for when the weather is very hot outside or very cold outside, just considerations to keep in mind when weighing the trade-offs here. Another best practice for teachers and staff is to avoid turning off the HVAC system during the day, and also keeping items that could block airflow out of the way of the air vents. And that's going to be critical for maintaining the integrity of the system. And then also training teachers and staff on the sources of indoor pollutants that may also contribute to classroom or room air quality. And that could include cleaning sprays or air fresheners or pollen-producing plants that might be inside. And then another key recommendation that I alluded to on the previous slide is that planning strenuous outdoor activities should be, they should be planned for when children are outside, should be planning these outdoor activities for when traffic pollution is lowest. And you can refer to the EPA's Indoor Air Quality Tools for Schools website, which is linked right here, to find resources to help train staff on indoor air quality management. So the advantages of educating staff on ventilation and indoor air quality best practices are that the HVAC system is then less likely to be turned off. The air vents will remain unobstructed and provide adequate ventilation without additional stress on the system. And the filtration won't be bypassed by opening doors or windows unnecessarily during periods of high pollution outdoors. And all of these will ultimately help prolong the life of HVAC filters or other filters that might be in place. So the initial and ongoing costs would actually be low in this case, as this strategy involves training staff and communicating with them. And overall, we can say that this this approach would result in a medium level of mitigation benefit. So next, we'll move to discussing upgrading school bus fleets. And so this is really focusing on replacing an older generation diesel buses, and especially those that are from 1998 or older, with the lower or zero emission options that exist. And this is to reduce the diesel particle emissions that are associated with these, especially older buses. And a co-benefit of doing this is that there's lower long-term maintenance costs associated with these newer vehicles, and they also have improved efficiency. So before COVID, and likely once all schools start to resume again in person, there were approximately 480,000 school buses traveling each day within the United States, and 95% of those are diesel powered. So upgrading the bus fleet, and again, especially those pre-1998 buses, with less polluting options such as newer model diesel, biodiesel, compressed natural gas, or electric, will reduce air pollution in general, but will also reduce the exposure to students that are on the buses and also in the areas where children are dropped off at school. And there's a variety of funding options actually available, including rebates, to help offset the cost of upgrading the bus fleet. And these are available at the federal, state, and local level. And there's also opportunities for working with local utility companies to secure charging infrastructure for electric vehicle options as well. So just one example of this is at the federal level is the EPA school bus rebate program offers rebates for replacing older diesel vehicles with 2017 or newer engine buses that could be diesel, gasoline, battery, or alternative fuels. And then at the state level, an example is the California Hybrid and Zero Emission Bus Voucher Program, and that offers up to $220,000 per electric school bus. But there's other states as well with clean school bus funding, and that includes Arizona, Nevada, Ohio, just to name a few. So the advantage of upgrading the school bus fleet is reducing the emissions of both gases and particles, and the potential long-term cost reduction that's based on replacement of the bus type that's been chosen. And the drawbacks are maybe the purchase price of the buses initially, and additional time it might take to train staff on maintenance that's required for upkeep of buses that are fueled by something other than diesel, as well as the potential route limitations that may exist due to the length of routes and the drive range of the buses that have been selected. And the initial capital cost may be high due to the initial bus purchase, but there's also setting up fueling infrastructure for electric buses or alternative fuels and training staff on maintenance. But keep in mind that the bus cost might actually be offset by some grants or rebate programs that are available. And the ongoing operational maintenance costs are low, especially for buses that are fueled in ways other than diesel. And something else to factor in would be possible ongoing training for staff. And so overall, the air pollution mitigation benefits associated with upgrading the school bus fleet would be in the medium range. Let me just click through, sorry, there we go. And so the last strategy within the operations approach is implementing an anti-idling campaign. And the idea is that an anti-idling campaign can help to reduce indoor air pollution by reducing emissions near building intakes or where students spend time outside, such as playgrounds or while waiting to be picked up after school.
No real one answer for everyone.
So the issues with vehicle idling apply to both cars and buses, and monitoring studies have shown that pollution levels increase during pickup of students that happens between 3 and 4 p.m. And sometimes the reason that people might idle vehicles rather than turn them off and back on is a claim that it would use more fuel to restart the engine. But it turns out that idling for more than 10 seconds actually uses more fuel than restarting the engine. So some recommendations to reduce idling include conducting an awareness campaign. And EPA's website, which we have a screenshot of here, has a toolkit for schools that has a toolkit for schools to use with resources for implementing a campaign. And so the toolkit has recommendations for how to conduct observations before the campaign so that you're able to document the idling problem at the school and then measure again after the campaign has ended or after your initial thrust of the campaign to demonstrate how effective the campaign was once it's underway. And so after documenting the issue, part of the recommended response involves distributing flyers to teachers or to parents, or putting up signs such as this one, which is available as part of the toolkit. And another asset of the toolkit is that it suggests an explicit schedule for when to perform different parts of your campaign during which months of the school year, which can be helpful. And it also gives strategies to really involve students through a variety of project ideas and suggests ways that students can conduct observations to really empower them to feel like they're making a difference. And another major portion, since we noted this is an issue stemming from both cars and buses, is required training on anti-idling for school bus drivers at the school. And again, just as a sort of a caveat or an important side note, it's also very important to keep in mind that local factors are going to play a part as to how much you can sort of enforce or recommend this, because during extreme cold or heat, it might be necessary for people to keep the AC on or to have heat on in the vehicle to prevent adverse health implications. So really something to keep in mind, depending on the climate that that the school is located in. So the advantage of implementing an anti-idling campaign would be a reduction in the particles and gases outside of the school building, where the students might spend time, or where, near the windows or the air intakes which draw air into the building. And the main drawback relates to a lack of climate control during hot or cold weather while the vehicles are off. And here, both the capital and operational costs associated with the strategy are again low, because they're associated with the cost of hosting and putting together an awareness campaign and training bus drivers and posting signs. And just as a reminder here, I know I mentioned it on the previous slide, but that factoring in local weather factors such as cold or extreme heat should be taken into consideration when implementing this strategy. And so that brings us to the building design approach, which concerns the layout of schools. So this might be more applicable to new upcoming schools rather than existing schools, although there are some changes that might be able to be made to existing schools within reason. So this is specifically referring to designing or reevaluating spaces within the schools to minimize exposure to pollution sources. So it's recommended that playgrounds or athletic fields and classrooms are as far away as possible from the road. So in this ideal schematic on the right-hand side, you can see that the school and the playing field are as far back from the road as possible, with the road being down here. And the bus and loading zone in the parking lot are also as far away as possible from the classroom and the play areas. And in addition, an important consideration is the placement of portable classrooms, and I'll describe that a little bit more in the next slide. So ideally, portable classrooms should be placed away from busy roads and parking lots. And they should also be oriented so that their air intakes, if they have those built in, are facing away from traffic. And overall, following the EPA guidelines for their operation and maintenance is really key. Another important point to be aware of is that unpaved, meaning dusty or dirt playgrounds or sports tracks, for example, can contribute to PM indoors as well, or air pollution indoors as well. So the best approach is to plan building air intakes, whether for the main building or for portable units, away from where these dusty locations are, and to keep windows and doors shut during outdoor activities that could generate dust from these sources. So the advantage of designing or redesigning schools in this way is that it will help to reduce exposure to both particles and gases, while the drawbacks are the effectiveness of how much air pollution reduction can be achieved, and that's because it's going to be largely site-specific. And again, this might be more appropriate for schools that are currently being planned, as it could be quite costly or infeasible even to redesign existing schools. So if we look at the cost table, the initial cost is high, as it might require redesign or implementation of changes. However, the ongoing costs would be low because once the school is redesigned, there should be no additional changes that need to be made. And with that, I'm going to pass it over to Doug, who will be talking about strategies, solid and vegetative barriers.
Thanks very much, Olivia. So as a refresher, let me just mention, as Rich and Olivia have both talked about, the strategies that we're introducing here can really address one or a combination of three approaches. So the first would be trying to reduce the actual emissions at their source. So if we think about the school bus retrofitting or updating, that would be cutting back the emissions. Secondly, trying to reduce the concentration of pollutants in the air. And then third would be trying to limit exposure to students to those concentrations. So I'm going to chat a little bit with you right now about using barriers between the roadway and the school site, which will hopefully be approaching the second two aspects. So we're not directly affecting the emissions or the vehicle emissions that are creating the pollution, but we are reducing the concentration of pollutants that occur at the school site and therefore reducing exposure for students. So I'm going to talk about the use of solid barriers like a sound wall first, and then I'll mention vegetative barriers such as trees and shrubs, where the concepts are very similar. So why don't we go to the next slide? So sound walls or solid barriers have the opportunity to cut concentrations of pollutants next to a major roadway by up to about half within the first few hundred meters, within the first 150 meters of football field and a half or so, 500 feet away from the road. There are some caveats or fine print around that. So if there is a solid barrier like a sound wall, or there's going to be the installation of something like that, you don't want that barrier to end close to the school site because pollution can sweep around the edge of the barrier and then wind up traveling over to the school site. Also, if there are gaps in the wall itself, and we've all seen sound walls where just from design purposes, there are occasional gaps or sections of wall where there are openings. You want to avoid having those gaps near where the school site is. Obviously, the gaps are where pollution can travel through. So these, if they're well designed, are a very effective tool, can be a very effective tool to reduce pollution just on that downwind side of the wall where the school site could be. And in that first 150 meters, football field and a half distance. There's also an opportunity to combine, and this, as is shown in this picture, vegetation with sound walls. And if the two are overlaid with each other, that can improve the effectiveness. And studies show that we could be cutting concentrations perhaps up to 60%. So why don't we move to the next slide? These are most effective as options really located next to particularly heavily trafficked roads such as highways, very busy roadways. But we recognize as well that the school district or the school site itself may not have jurisdiction over the building or implementation of these barriers along the roadway next to the school. So if this is something that seems to be a particularly useful option for your site, then it would be important to contact the relevant jurisdictions and agencies that would control for that. And typically that's going to be the State Department of Transportation for major highways or interstates, or your city planning department if it's a more local road. Next slide. So the advantages of these are that it has a direct impact on cutting concentrations and reducing the pollutant load that's right next to or downwind of these barriers. And as we've talked about other strategies like using HVAC system filtration, those strategies, especially HVAC filtration, focus on removing particles. In this case, if we have a solid barrier next to the road, it actually can affect both particles and gases. So it applies to all of the pollutants that are being emitted at the roadway. The drawbacks, of course, are that there could be substantial cost involved in setting up a barrier. The design needs to be carefully thought through for the individual site so that you don't wind up, as I mentioned earlier, creating an edge or an end to a wall right next to the school site and allowing pollution to sweep around those edges. And these are best suited to freeway settings. This is one of those mitigation efforts that we're ranking as part of that medium category of effectiveness here. The capital costs will vary. We've seen, for example, in Southern California, costs that are on the order of $10 million per mile for a sound wall, whereas in other locations in the Midwest, such as Ohio, the costs may be on the order of $2 million per mile. So these costs will vary depending upon the state and the location. On the positive side, there are relatively low or perhaps in some cases no operational or maintenance costs associated with putting up a wall. Why don't we go to the next slide? So in addition to a sound wall or solid barrier, we can also think about using vegetation. And these, the benefits of a vegetative barrier are very similar in concept. Why don't we go to the next slide and I'll chat a little bit more about that. So here are a couple of illustrations showing different settings and different types of vegetation. Similar to a sound wall, when you have a very thick, almost very dense solid mass of vegetation, what that does and what each of these, both solid as well as vegetative barriers do, is essentially it forms a barrier and prohibits the pollution from directly moving from the roadway straight to a downwind school site. So instead the pollution is lofted up. It has to travel up and over this barrier. And when it does that, it moves downwind at a higher level away from the ground where school children are located, and the pollution is dispersing while that's happening. Then when that air mass eventually reattaches to the ground, the concentration of the pollution is much lower than when it originated from the roadway. So both of the solid wall and vegetative barriers have that kind of an impact. Vegetation also has the added potential benefit of acting as a filter so that as the pollution travels, some of it through the vegetative barrier, the vegetation itself can help to filter some of those pollutants out of the air. And that will depend upon the type of vegetation, its leaf structure, and whether it is thick enough to prohibit all air from moving through or allowing some of that air to pass through. Why don't we go to the next slide? So because there's many different types of vegetation, and we can all envision how this would be very variable depending upon what part of the country you live in, what your climate is like, and the rest. There are a few important things to consider here. So first, we really want, from an air quality perspective, to have a very thick, dense structure of vegetation for this to be an effective barrier to pollution. So that would mean if you think about how over the course of a year, depending upon what part of the country you're in, if you have deciduous trees, they may lose their leaves during parts of the year in the fall and winter. So evergreens tend to be a better choice for this type of vegetation, and will retain that structure that we're looking for to protect children from exposure. Also the needle-like greenery of evergreens tends to be a more effective barrier in the air pollution context. It's also important to think about that many trees and vegetation, as shown in the pictures on the bottom, as those trees mature and grow, near the base of the trees, there can be a gap that develops. So often what's thought about is combining the planting of trees with shrubs that will help fill in the gaps. Sparse vegetation such as that shown below is not really going to be an effective barrier here. Why don't we go to the next slide? So overall, vegetative barriers, very similarly to the solid barriers, have the opportunity to reduce the concentration of pollutants. So we're not cutting the emissions from the vehicles, but we are reducing the pollutant concentration that occurs just downwind from these barriers. Vegetative barriers have the added benefit of potentially having aesthetic qualities that could improve the characteristics of the site. So more shade, there's the opportunity to provide a nicer looking environment, especially if there are communities that lack much vegetation, which occurs in some disadvantaged communities in particular. The benefits will vary depending upon how close the school site is to the roadway, and the area that's most improved by the use of vegetation is that first 150 meters or so just downwind of the vegetation. There are costs associated with a vegetative barrier that you don't see with a solid barrier, because there could be ongoing maintenance costs associated with the vegetation, irrigation, especially in the early years when, if they're using tree planting, it may take several years to establish the trees until they begin to grow to maturity. And there might be a special need during that window for extra care and maintenance to ensure that the trees and vegetation take root and grow appropriately. So these are together, packaged together, solid and vegetative barriers can work synergistically, and either one or the other, or in combination, offer some important opportunities to reduce exposure. I'll turn it back to Olivia. Thanks.
Thanks, Doug. Okay, so in order to make it easier to digest sort of all of the strategies and the information that we've presented so far, we've synthesized this table. And so what we're doing here is showing the strategies along with the benefit level that we've assigned, and also the capital and ongoing cost level. And so they're colored also based on the level, with the darker colors meaning higher and lighter colors meaning lower. So we can see, for example, that HVAC improvements would provide the highest overall benefit, but the cost associated with the capital cost is high, while the ongoing cost is low. So this table can be used after this presentation as sort of a way to initially assess which strategies might be a good option for you or your school based on the resources that are available. With that, I will summarize. So we've covered a lot of strategies. So those included upgrading the HVAC system to be compatible with high efficiency filtration, educating staff on indoor air quality best practices, upgrading the school bus fleet to newer models that are diesel or alternative fuel, implement anti-idling campaigns at the schools with both the teachers, parents, and bus drivers, relocating air intakes for the HVAC system if they happen to be near pollution sources or facing pollution sources, optimizing occupant placement at the schools, which is an important consideration, especially for new schools when they're being designed, and then considering the implementation of vegetative and or solid wall barriers. So before we wrap up and move on to the Q&A section, we have our last poll. So I will go ahead and launch this one. And this one actually has a number of questions involved. So the first one, and you'll have to scroll down to see them. The first one is, do you think the best practices document contains information that you could use? And then the next one is, of the mitigation options that we've presented here today, which do you think might be the most promising and feasible to adopt by the schools or the school district that you are most familiar with? And then question 8, similarly, is, of the mitigation options that we've presented, which do you think might be the most difficult to implement by the school or school district? And you can select multiple options for these 2 questions. And question 9 is thinking about the school or school district, again, that you're most familiar with. What do you think the key barriers to the adoption of these best practices might be? Question 10 is, what is your primary field of interest? Just so we can get a better idea. And then the very last question is, would you be open to providing more in-depth feedback about the best practices document in the future? And I know there's a lot of questions, so I'll just give you maybe a minute or so here to work through those. So you can see the numbers ticking up here. I'll give you maybe 30 more seconds. Okay, and I'll close it in 3, 2, 1. And we'll share the results with you in case you're interested in seeing them. Okay, so it seems like a lot of people, 98% of the people that responded here think that this document contains information that they could use in the future. And that is fantastic. Awesome. So with that, I will let you know that, let me just minimize this. If you have any more questions or you want more information, please feel free to reach out to myself. I'm the Sonoma Technology Lead on this project, or Rich Baldoff is the US-EPA lead on the project, and we would both be more than happy to answer your questions or provide more information if you need that. And again, you'll have these slides, so you'll have our email addresses on them. Okay. And then we would like to acknowledge that this work was supported by a number of different US-EPA offices, including the Office of Research and Development, OTAC, Office of Sustainable Communities, the Region 9 Air and Radiation Division, the Office of Children's Health Protection, and an additional thanks to the Bay Area Air Quality Management District for answering some questions when we reached out to them. And with that, I will now open it up to our panelists who have been monitoring the Q&A section and ask if there are any questions that we would like to answer live at this time. And if you want to unmute yourselves, panelists, you can do so. And again, if any of the attendees have questions, please feel free to keep posting those into the Q&A section and we can answer them if they haven't already been answered.
Hi, Olivia. This is Ken Davidson.
Hey, Ken.
I did want to, we had a few questions about providing some of the information that we've tried to convey in real time in the Q&A, especially the links to additional resources and information regarding the topics we discussed today. And to reiterate, in addition to the materials and the recording for today's webinar, we will compile and provide a link, provide those links to resources that we've provided in real time today. So I just wanted to make that point for our active participants on the Q&A. Thank you. I'll also, since I'm unmuted myself, will mention there have been some questions related to barriers and vegetation barriers on buffer projects in particular. And in our links, we provided the link to guidance that EPA and Rich Baldoff has pulled together on best practices for vegetation barrier planting. And I may give him an opportunity to chime in, but we did have one question asking about vegetation buffer projects that have succeeded in densely urban areas. And this is an active area of research that Rich and myself and others at EPA have been involved with. And while we don't have the results from our vegetation buffer work just yet, we have partnered with local air districts and schools. We went to school in East Oakland, Brookfield Elementary School, where we tried to get off the ground a buffer project there, and as well as at a park in Detroit. So there are other projects that are occurring right now on buffer, and we hope to get more information as they mature and hopefully mitigate near-road pollution. But Rich, if you have anything to add.
Yeah, thanks, Ken. I appreciate that. Yeah, and I would just say that, yeah, in addition to the two projects we're aware of in the US, there's actually one other one in Louisville, Kentucky, where they're looking at implementing some vegetation planting at a school and also monitoring air quality before and after. That's also a fairly recent project as well. And then there have been some studies, also very recent, where we're still waiting on results in Europe as well. And you know, one thing we could probably do is provide some additional links to that work as well that was supported by the European Union. So, but yeah, I think that's, and one thing maybe I could add just in general is, as you mentioned, Ken, it's lots of like requests and questions about updates, links, updated information, guides that EPA or others have. And I think this is really helpful for us too, as we're looking at, you know, reviewing and updating this report, is that, you know, I think these will provide great opportunities for us, and, you know, that you helped us with to identify, you know, these issues and resources that will be useful in including in the update as well. So again, I just wanted to say thanks for that.
Are there any other questions in the Q&A that we should address?
Olivia, I think it might also be useful, since it did come up in a few questions about resources that are available funding both at the national and at the state and local level. I think we have an additional slide. And where we could, we tried to provide links to some of this information, particularly on the school bus rebate program and other funding opportunities through the Diesel Emissions Reduction Act. So again, those we provided in the Q&A, but can provide those links after today's webinar. I wondered though, Doug, maybe if you wanted to talk a little bit about perhaps the response you've given to one of the questioners in the Q&A. I think that might be useful for the audience today.
Thanks, Ken. That makes sense. When we look at schools that are located next to roads, often communities that are next to heavily traveled roads, the literature shows pretty clearly that those communities are more often disadvantaged communities and can be communities where there's a greater proportion of the population that are minority or lower income status. And there are a number of programs that are trying to provide resources, financial resources, to address pollution problems in those disadvantaged communities. And I'm going to give an example in California, where in California, there is a program under a state law that was passed in 2017 called Assembly Bill 617 or AB 617. And that program redirects and gives focus to community-based resources to try to address air pollution in disadvantaged communities. And so there are grant programs under the AB 617 program that community-based organizations can apply for grant funding in those areas. There is focused work to look at areas that have high pollution concentration, and then local agencies are tasked with making more specific air pollution reduction program efforts in those high pollution communities. So those individual air districts at the local level also have resources that they are promoting and putting into use in areas such as near road environments where we see higher concentrations of pollutants. And then finally, also continuing with the California example, there are resources that are available under what's called a supplemental environmental program or a SEP program that the state agency in California, the California Air Resources Board, makes available for communities and organizations that are trying to implement environmentally protective programs or projects. So as an illustration, one could envision that if there were a school district or other community-based organization that wanted to fund HVAC filtration improvements at school sites, that kind of work could be eligible potentially for funding under that SEP project or program that the state has. So I think the big picture is, and I realize not all of you are from California, the big picture that we're trying to share here is that there are federal program resources, as Ken's mentioned, and then there are also, depending upon what state and what area you're in, we would encourage you to contact your state agency staff, and also if you have a local air pollution control agency or authority, to look for grant funding that may be available from those resources as well.
Great, thanks, Doug. And I'll just chime into the best practices document that we covered today. It was published in 2015, and for any static document, it would be difficult to track all of the different funding opportunities that are out there. But I think that's something for us to think about in the future, and as we update our guidance, how to perhaps track and publicize that information. So thanks to everyone for their questions on that.
Ken, can I say one other thing on that topic? Because one thing that we've talked about is when we put this guidance together, when EPA made this guidance available, originally, obviously, it was in that pre-COVID era. And one of the things now that we're in the COVID window, of course, we can't predict and we don't know whether there will be another stimulus package and further federal funding that comes forward for that program to deal with COVID issues. But if there is, we want to just alert you that there are opportunities here for co-benefits. So if we're thinking in terms of schools that would receive funding to address COVID through HVAC system improvements, the guidance on that we're making available as part of the slide presentation afterwards, the link to the guidance on that, talks about how MERV rated systems that are at 13 or above are HVAC improvement levels that are likely to have important benefits to help reduce and address COVID inside the school environment. Well, there's direct overlap between that type of MERV rated HVAC improvement and the ability to try to address indoor air pollution, as Olivia and Rich have talked about, earlier in our talk. So the point that I think we want to share is that there may be a window of opportunity that opens up that's related directly to COVID in terms of funding, that if you have the opportunity, you could take advantage of and would have dual purpose and offer benefits to address these longer term issues of dealing with near road pollution, as we've talked about here today.
Chad, Ken, or Sarah, are there any other questions in the Q&A that we should address that haven't already been addressed?
Yes, this is Sarah. I want to take on a question about addressing wildfire smoke events and air pollutants in schools. So we have a webinar coming up this Tuesday, and I will put the information, a link to that in the chat, specifically talking about children's health and wildfire smoke, as well as green cleaning, sanitizing, and disinfecting. So we'll have experts from the Western States Pediatric Environmental Health Specialty Unit. And while it's not specifically about schools, it is about protecting children during wildfire smoke events. So I'll share that in the chat. I'll also say that there are resources available. airnow.gov/fires has resources on wildfire smoke, and we have a wildfire smoke toolkit that I can also share.
Any other questions that we didn't get to that we should address in the last minute or so? Ken, if you're talking, we can't hear you.
I was sort of talking to myself. Right, there has been some back and forth about vegetative buffers. Thank you to folks who are providing that information to the project in Louisville, as well as the Sacramento guidance, which I think, Rich, you may have, if not, of course, aware of, may have coordinated on. There was reference to the VW trust mitigation funds for how different states are administering those, so that's an excellent point. And then I think we've really addressed most of what is hanging out there. So I'll pause and let the other panelists chime in.
Okay, well, if there's no other questions that we haven't addressed, we can go ahead and wrap up. Rich, do you have anything that you'd like to say to close this out?
Yeah, sure. Thank you, everybody, both for the presentations and all the participants as well, and all the questions. As Olivia had mentioned, there'll be recordings and the slides will be available. If there were questions that you did not have a chance to ask, again, please feel free to email us with those questions, and we'll share with the other panelists as well and provide responses. And again, too, if you've had a chance or will plan to look at the guide in the near future and have any recommendations for us as well, and any ways to update information in there, or even just maybe ways to update or improve, how the information is presented. We would greatly appreciate that as well. And please feel free to contact us with that. But otherwise, again, I appreciate everybody's participation, and thank you, and wish you a great rest of your day.